You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Podcast. I'm your co-host, Dan Blewett. On today's episode, pretty wide slate of topics. First, tragic helicopter accident. Olivier Dassault has passed away. We'll talk a little bit about his legacy. Obviously, a huge aviation family. 777 engines, that big, crazy failure on a recent flight, a United Airlines flight. They've got some information about what that might be, some metal fatigue. NASA's X-57 Maxwell electric is moving along and through the prototype stage. Netjets has bought 20 supersonic jets from Aerion, so that's a pretty big order. In our engineering segment, we'll talk about Liquidpiston, their rotary engine, which is really interesting, 10 times the power, 30% more efficient. And lastly, in our EVTOL segment, we'll talk about Kitty Hawk and some potential healthcare uses, Rolls Royce, and Joby news. So, Alan, let's start with Dassault. So, obviously, this is a generational family. I mean, and helicopters continue to claim the lives of, some pretty prominent people. And you've been pretty outspoken about helicopters in general. What's your take on the situation? Obviously, a tragedy.
It's definitely another tragedy. Helicopter accidents seem to be a little more catastrophic in a sense, just because they don't always have any way to really fly. Once you have mechanical problems, you're in trouble. Now, there hasn't been a lot of information come out about the accident as much as it's just been announced. And the Dassault family is a very famous French family because they're the originators of the Dassault aircraft line. So Olivier's grandfather started that aircraft business way back when. And the Dassault aircraft business is one of the sort of the premier businesses, aircraft businesses on the planet. They make a beautiful set of aircraft. I mean, there's no other way to describe a Dassault aircraft, but it's just a beautiful aircraft. Everything about it is smooth, unique, aerodynamic, very well thought out. It's like a piece of art. So if you're flying it at a Dassault, you're kind of set yourself apart a little bit. And that company has grown and shifted over time. Obviously, they're in the military business for a long time, and then on the civilian side with their jets. And the Dassault family has done very well off that aircraft company. But Olivier was also involved in French politics. So there's that unique tie, and I think Dassault plays that one of those unique roles in terms of a French company as being as large as it is and as much revenue it has generated over a time, where they've been able to essentially remain separate from the French government, but the French government is involved. So the Dassault family sort of crossed that line between business and politics and being able to sort of walk that line, because at times I think Dassault was, when there was at least some implications that Dassault was going to be completely taken over by the French government. So, the loss of those family members is a big loss to the French community, I think, in general. So our thoughts and condolences go out to the family. But the Dassault legacy lives on, and it will continue to live on because they make great products.
Yeah. It's scary when you start to, obviously everything, the news cycle today, like anything can be reported, right? So maybe there were a lot more helicopter accidents back in the day that weren't, it wasn't as public as it is today, but with Kobe Bryant and now, Mr. Dassault, it just seems like, man, you're almost rolling the dice taking a helicopter ride. And that's what I know you've talked about with EVTOLs, that having a lot of rotors and a lot more redundancy is a really good thing for the safety of helicopter travel.
It is, and it will be a lot safer once we can get to that, something that actually works in the EVTOL market. But helicopters have done there's been a lot of changes to helicopter design over the years, where more safety systems have been installed and more monitoring systems have been installed, and the maintenance has gotten so much better over the last 20, 30 years on helicopters. So the reliability has gone up, but the fundamentals of it are, you got a rotating wing out there, and if it stops rotating, bad stuff happens. Now, we need to hear more from the French investigators on what was the cause of the accident, because the Kobe Bryant one was they essentially flew into the side of a hill, which is pilot error, and a lot of accidents today are still pilot error, not mechanical failure. Yeah.
Well, and speaking of redundancy, the Boeing 777 which made national and world news a couple weeks ago. And that just showed the power of redundancy. There's a burning, flaming, destroyed engine, and the plane continued on just fine and landed safely, which was pretty amazing. But it sounds like they're confirming that metal fatigue was the main factor here.
Yeah, those inlet fan blades are made out of metal, and they are inspected. And there's a schedule to inspect them. I think it was around 9,000 cycles, which is takeoffs and landings. And in that particular set of fan blades was around 6,000 cycles, if I remember correctly. So they had a long time.
6,500 is the next inspection cycle, but this one was at 2,979. So yeah, about halfway there.
So it had a long way to go before it got to the next inspection cycle. So what will typically happen in these situations that they'll take the remaining pieces as they can find them and do metallurgy on them to see if there's something unique about the metallurgy. Did it have the right mixture of metals? Was it something about the heat treatment? Has it aged over time in some unique way? Was there some damage that was not detected on those blades earlier? So they'll go back and look at all the flight logs to see if it had some weird thing happen. Somebody bump into it. There's a lot of different ways you can damage and fatigue metal. So they're going to be doing a lot of work on the engineering side for the next year. It's taken probably a year to really get down to the heart of the matter, what really caused it and how it cycles out, because the question isn't what happened to that particular engine, is what are you going to do about all the engines that are continuing to fly right now? Do you need to inspect them every 1,000 cycles, every 2,000 cycles? There's going to be some change made there. Obviously, at least that's the indication right now. They're going to make some sort of change on the inspection cycle. The question is what, and what's the FAA going to accept? So there's a lot of work at Pratt Whitney right now. A lot of work at Pratt Whitney.
So speaking of multi-rotor aircraft, the NASA X-57, which is a electric plane, is getting closer to liftoff. It's now into high voltage functional ground testing. So Alan, what does that mean? How far along in the stages is that?
So they have a multi-stage program to evaluate electric aircraft. And the first stage is basically taking Technam aircraft, take off its gasoline or aviation-powered engines, aviation fuel-powered engines, and put on electric engines and go out and demonstrate that they can fly the aircraft with electric engines, get some numbers on the electric engine performance. And then there's a couple more stages after that where they move the electric engines out to the wingtips. And then I think the final stage is they add a bunch of electric motors onto the wingspan. So there's like 3 stages of development there. And each one of those stages is going to take several months or years to do because of the mods you have to make to the aircraft. So NASA is a very important engineering leadership group in terms of driving the industry towards the next generation of aircraft. The problem right now with the X-57 is it is behind. The Jobys of the world are going to be up and flying aircraft that NASA will be 3 years behind, 4 years behind. So Joby will probably be done while the X-57 is still kicking around. That's a problem because NASA should have been leading that, and it's difficult because NASA doesn't make aircraft, right? So they're having to justify the expense of doing this exercise, the stages, the safety aspects. There's a lot of infrastructure there, and a company like Joby can just go, we're going to throw $1 billion at it and go. And NASA can't do that. And that's where that disruptive company aspect comes into this, is that NASA is going to be following behind them. And it's not necessarily a bad thing because NASA is going to be providing data for the industry, but the Jobys of the world will already be done. And they will already be done and flying, hopefully.
Well, and another interesting aircraft, so the Aerion AS2, which is a supersonic business jet, Netjets has just created a purchase order for 20 of them, and they're $120 million price tag each. So, $2.4 billion purchase order. And it says Aerion has a backlog of more than 10 billion in orders, according to this article from Rob Report. So pretty interesting that Netjets is, which is they have the largest business jet fleet, and they're a Berkshire Hathaway owned company. So it sounds like they're making a pretty big bet on supersonic. I mean, where do you fall on supersonic?
It's going to be a very fascinating policy discussion on whether supersonic's going to be allowed or not. I think that hurdle still remains. I know the FAA and NASA are willing to put down the engineering to make quieter sonic booms and try to get the policy changed in the United States, and then obviously in the world. It has to be in the world. So the question is, are they going to be able to get the policies changed where you can fly these supersonics and actually, quote unquote, break the sonic barrier over land? Or is it going to have to always do it over water like the Concorde did? And the Concorde model sort of failed doing that. I always wonder when you hear about aircraft contracts and aircraft sales, there's a ton of contingencies in those contracts. If they don't hit certain milestones, Netjets, everybody else will just back right out, or they'll ask for a price decrease in the aircraft model to compensate for the loss of revenue that they would have had if the aircraft had been certified by X date. Those things play into the valuation of a company heavily. But those contracts are never fully disclosed. But just think about writing a check for $1 billion, right? You're going to have a lot of contingencies if this aircraft isn't delivered on time and meets its performance numbers and all those things. So always take these aircraft contracts and these theoretical backlogs as nice to know, but until you see real progress and aircraft coming down the production line and they start hitting their flight test goals and start meeting their performance numbers, it's sort of meaningless.
So let's move on to our engineering segment here. Today we're going to talk about liquid piston, which seems really, really interesting. So the liquid piston engines, they are a rotary engine. They're not the Henkel engine. And I think they do a great job on their website, just explaining and showing their technology. I mean, with a lot of aerospace companies, a lot of times it's kind of theoretical, and you don't necessarily get a really good dive into what makes their technology different, especially in like the EVTOL space, right? There's a lot of, here's a lot of prototypes, but they don't really give you the nuts and bolts. But with liquid piston, they're very forthcoming about this is what our engine does. You can see it, still in motion, all sorts of stuff, which I found really interesting. But the Henkel engine is a triangular shaped piston and a cylindrical or an oval shaped Alan, what's the
cylinder? Sort of, yeah.
Yeah, and then with the liquid piston engine, it's sort of the opposite, where the rotor is cylindrical and the piston and the rotor is the piston is like a potato shape, yeah, and the cylinder is more of a round more of a rotary shape. So really interesting. And I think so. The big news here is that liquid piston has won an Air Force contract to kind of say, hey, we know these EVTOLs have a battery limitation, right? Where there's a major shortcoming in energy density. So what other types of engines and propulsion systems can work to fill this gap if battery power isn't going to be realistic to fuel these flights in the near future? So liquid pistons won a contract from the Air Force to develop more of these engines to fit that need. So Alan, how do you feel about this rotary engine technology? It looks pretty interesting to me.
It does look really interesting, and you're right. They have done a great job on their website describing the technology and giving you videos and things to look at about how it works. The technology is very interesting because I think, like the Chevy Volt, the first generation of these electric aircraft are going to have some sort of redundancy system, fuel-based system, where they have a little engine, like liquid piston engine, creating power to just basically backfill the power that's used during flight, so they can either extend the range or provide the necessary reserves in case they get into a situation where they can't get out of. That happens all the time. You fly into bad weather, you turn around and go back. Those kind of unexpected alterations of your flight plan sometimes require that you carry more fuel, which is what a lot of aircraft do right now. But on an electric aircraft, a battery-powered aircraft, you just limited space for batteries, and batteries are heavy, and all the things that go with it. How do you design the electrical system to meet all the FAA requirements? Well, one way to do it is to put a basically a motor backup, a generator backup into the aircraft, and have a small fuel tank there just to do that. And the liquid piston design is really interesting because it's pretty compact, and yet it delivers a decent amount of electrical power out of it. So it would seem like it'd be a really good fit for the electrical EVTOL market. That would make a lot of sense to me now, and particularly since other standard jet engine manufacturers are playing around in the electrical space. You got to wonder if someone like Liquid Piston is not going to get acquired by a Pratt Whitney or a Rolls Royce or somebody to take that technology and then to manufacture it on a large scale. You can imagine, Dan, if you're trying to, like any engine manufacturer, if you have to build thousands of these engines a year, which is what we're talking about, the amount of human resources and facility and equipment and all that it's going to take a huge investment. And there's a limited number of companies in the world that can really do that efficiently, unless you get an influx of like investor money to do it, but you're still starting from ground zero. So that even though the technology is cool, don't you think they're going to need somebody else to help them bring it to reality? You have to partner somebody.
Maybe, yeah. Well, and it just seems like a big task in general. So their X engine, which is their next generation rotary diesel, which is the one here in question, the Air Force wants to see if they can help them get that out there and provide that propulsion through a hybrid electric system. So yeah, I mean, like you said, there's a huge combination of challenges, and this seems like a really big task to get these aircraft to market. So yeah, but the X engine, 30% more fuel efficient than a diesel engine, with 5 to 10 times smaller and lighter size. So that's pretty amazing.
Right. It is amazing, and it's surprising you haven't seen the technology being implemented somewhere else right now. But it must be the manufacturing cost to build the engine must be higher. It is a little bit complex in the way it's built. But someone like Pratt Whitney or Rolls Royce or GE does that every day. So I think there's a good fit there somewhere.
So let's shift into our final segment about EVTOLs today. So first, Kitty Hawk, which has their heavy side aircraft, they're looking to partner with Falck, which is a Denmark-based emergency services and healthcare company, in this article by EVTOL.com. And I think this makes a lot of sense. I mean, we've talked about that everyone wants to do these, hop over to work, taking an EVTOL, right? That's like the commuter thing. But the fact that you could use this as an ambulance or to provide other emergency services, maybe to transport an organ that needs, a hospital needs an organ, a couple 100 miles away or whatever, that seems to make a lot of sense, where this is in the commercial space first before being in this commuter space. And so Falck says they hope to introduce the heavy side in Denmark first, and then move to the U.S. after that. I mean, how do you feel about this development?
I think it's a good choice. Helicopters that service the hospitals and emergency services are used fairly regularly every day. They're the kind of workhorse helicopters right now. That's what does that job. To bring in something electric probably has its advantages in terms of speed. Top cruise speed is probably going to be higher on some of these electric aircraft, and efficiency. It does lend itself to that particular market, and that's a little more of a difficult market in a sense of, in the commuter world, your flight may be delayed by 5 minutes as the aircraft recharging. You really can't do that on an emergency services helicopter. When they have an emergency, that you have to be able to go and deliver the service right then. So that puts another level of complexity on it. We got to be able to quick turn these things back around and get them back into service again. How do you manage that? Because in an existing helicopter, you put some fuel in it and you go. I think it's taking a little more of a step up in terms of the risk from a company standpoint, because the aircraft really has to deliver. It can't be down with service issues. It can't be down because it needs to be charged. It has to be available essentially 24/7. So that adds more engineering task to do in terms of its performance. It's an interesting take. I think it's a good marketplace for them. But on the engineering side, you have a little more work to do, I think.
for sure. Well, speaking of the engineering side, so Rolls Royce is going to be partnering with Vertical Aerospace and providing their electrical power system in the VAX4 EVTOL, which is a pretty interesting commercial deal for these two companies. And you think this is a pretty good thing for Vertical Aerospace because Rolls-Royce brings a lot of expertise to this space.
They do. They're bringing engineers, like over 100 engineers going to be working on this project. And Rolls-Royce, much like GE, much like Pratt Whitney, know the propulsion industry, and they have engineers that know how to certify propulsion systems. So you're bringing in the real experts. Now, they don't have a lot of experience in electric motors, so to speak, because it's a relatively new marketplace for them. But they know all the regulations, they know all the intricacies, they know what testing is required to go off and certify an engine, so to speak, in this case, a motor. And the power distribution system comes along with it. So instead of Vertical Aerospace devoting a lot of resources to develop the power distribution and propulsion system, you're handing it off to a company that is world experts in that. So you can take that off your plate of things to go do. You can focus on designing the aircraft, all the avionics, all the other tests you have to go do flight tests you have to go do to certify an aircraft, and rely on a known, proven expert company and their engineers that you kind of have working with you directly to provide probably the most critical piece, which is the propulsion system. So it de-risks, in a sense, the program from Vertical Aerospace's standpoint, and from their investor standpoint, it adds a lot of confidence to the chances that they're going to be able to certify it. That's a huge development. If I'm not an investor in this space, and Dan, you're not an investor in this space either. But when I see a company, a known, proven company, kind of walk into that situation, it adds a lot of confidence. It should add confidence for investors that, hey, this is going to happen, right? Rolls Royce is not going to, most likely, not going to stumble and fall here. They're going to know where those trap doors lie, and they're going to be able to navigate around them through the certification program and give Vertical Aerospace essentially a push ahead of other companies that don't have that resource. So good move. I think it's a really good move. It's very fascinating that Rolls-Royce is driving so hard in the electrical space, because they've been such a leader in the aviation fuel powered jet engine space forever, that they're already transitioning over. They see a potential marketplace, and they're trying to capture it before some other, like a GE or a Pratt Whitney, try to get in that space. Rolls-Royce has been driving there pretty hard the last couple of years. So this whole arrangement makes sense to me. Makes a lot of sense.
Well, and there's been a lot of these partnerships just of late in general, right? I mean, it seems like, and of course, I'm sure all the CEOs of all these companies are like, hey, this company in our industry partnered with them. Maybe we should start exploring some of these partnerships. I think that's a natural thing. One person takes the plunge and says, hey, we're going to, move into this sector. Other companies start to think about, well, why are they doing that? Does that make sense for us? Do we need to be competitive there? How long can we wait? Are we going to really lose, and have a lot of ground to catch up if we wait? Or should we just jump in now and see what happens? And so it seems like, there's been a lot of these partnerships recently. Like you said, people coming in, whether it's avionics or motors or electrical systems, whatever, like, hey, let us help. We've been doing this for a long time. So I think that makes a lot of sense.
Just from a company standpoint, this is my take on how to build an EVTOL. You connect with a propulsion power provider, batteries, electrical distribution system, motors. Get that resolved. Just like you're building a standard conventional aircraft, you're going to hire Pratt Whitney to make the engine for it, or GE to make the engine for it. So you're not going to worry about that part of it. So you find somebody who can do that part. On the avionics side, your choice is probably Garmin, for a lot of reasons. One, cost; two, technology; three, the autonomous flight piece they've been doing with, like, Cirrus, whether you have the autonomous land feature where you just push a button, the aircraft lands itself. So they already have that sort of autonomous stuff going on in Garmin. You have to know that Garmin could make your aircraft, if the FAA would allow it, if Garmin could make your aircraft autonomous, which is where they all want to go anyway. So, hooking it with a Rolls Royce, hooking it with a Garmin. In terms of flight controls, there's a couple of key companies that you could connect with that could do flight controls, actuators, that kind of thing. Connect with them. If you can put those pieces together under one umbrella, where the aircraft company is developing basically the flight characteristics of the aircraft, the shape, the passengers seats and then the comfort areas and the touch screens and whatever else is going to go on, because there's a lot of work to do there. Let the aircraft company develop the aircraft, let the experts in the subcomponents, but still critical pieces, let them develop those components for you as a quote unquote partnership. Now it's not really a partnership, but because they don't ever seem to lose any money on the propulsion side. But that's your fastest way to certification, to de-risk it. Because if you have investors of $1 billion+ into this thing, you need to de-risk it. You need to have some means of de-risking it, and that's how you would do it today. That's how a standard aircraft would do it today. When you watch these companies develop new aircraft, that's kind of what they want to do, because it just takes pressure off. Even Boeing does it, right? And so Boeing will try to de-risk a program by bringing in large suppliers to do certain sections of the aircraft to hopefully de-risk the program and get it out the door so it can get certified. It's a huge deal to do it. So
last on our docket today is Joby Aviation. So they're going public at a $6.6 billion valuation through a SPAC. And, they revealed a new YouTube video about 2 weeks ago showing, their aircraft in flight. But it was only, a couple minute video, right? So, Alan, where do you fall? You have a lot of strong takes on Joby and the sector in general. But, it seems like Joby is one of the leaders, obviously. They've got some great technology, but yet to see flights that are near what they're claiming that they'll do in service, right? That 30-minute magic window. And obviously, you said there's going to need to be maybe 45 minutes of total flight time in reserve, right? Because obviously you can't be maxed out and at risk of crashing if you're, have to turn back or whatever. So, I don't know, what's your take on the latest with Joby?
I think Joby's making a lot of right decisions at the moment in terms of the way they're partnering, the way they're raising funds, because I think they have a realistic assessment of what it's going to take to produce and deliver aircraft and operate the aircraft. So they're raising money like they know what the final cost is, and they're realistic about it, which is a lot of times the hardest part for an aircraft company CEO to grasp, is it's going to take a lot more money than you think that it's going to take, and Joby seems to be around the number I think it should be. But the real driver, I think, and I go back to, we need to have some. And I'm not an investor in this space, and nor I'll be an investor in this space, but I think to prove the technology, you need to have a 30-minute flight with either simulated loads, passenger loading in it, or passengers, flight test engineers, and a couple of dummies in the back to show that the aircraft does what you say it can do. And EHang recently did that with an empty aircraft, where they flew it, and it basically put a couple of cameras in it and flew it across a lake for about 15 minutes. So you can see all the video from takeoff to landing. It's about 15, 17 minutes, if I remember correctly. So it's like a full-length flight. It's not 30 minutes, because I think 30 minutes is that really criteria where you need to get to. But it does show you what needs to be done in terms of, because they've had an investor confidence issue recently. And so to sort of get the investors back locked in, they've shown that their aircraft can do what they're saying it can do on some level, even though it was empty at the time. Joby's going to be in that same boat. All of the aircraft EVTOL companies can be in that same boat. Beta and Heaviside and all these Wisk are all going to be in the same boat, which is that until you show that you can do the real flight,
yeah, the product's not really there.
Right. It doesn't mean on the engineering drawing board that the numbers don't show that they can do it. They must be having some investor conversations about, can this aircraft do this? Here's the calculations. Here's the aerodynamic analysis. Here's all the basically a preliminary design review type presentation, which would be showing that they can do it, or a critical design review, a CDR, which shows that they can do all these little pieces all connect together, and they can deliver what they say they're going to deliver. The question is, from the public standpoint, you haven't seen it. And if you're trying to raise money through a SPAC, which is what they're doing, and you've got connections with Toyota and now former Uber Elevate, and you have all these pieces coming together, you still haven't shown how it's going to work. and then can it do what it says it's going to do? That's a huge hurdle to get over. And Dan, do you think you're going to see, this is 2021, so do you think we're going to see this year somebody do that 30-minute flight? Does it feel like that? Are we close?
It doesn't feel like that. And it is weird in the sense of all these different startups, because I can't think of another startup that has a product like that where, like you think of like a Dropbox, like, okay, Dropbox, but it's never actually stored a thing in the cloud. You know what I mean? Like Dropbox from the beginning was like, this needs to do cloud storage. And so even with Tesla, like they had their first prototype cars, years ago, and I don't know, like it was clear it could do what it needed to do, but this is like you said, it's very unproven. It has to be able to go 45 minutes with reserve to have that viable model, that business model. And so it really is a fascinating thing where it seems fundamentally different than all these other startups where it's like, well, if it doesn't meet that distance, what happens? Yeah, like is all this money gone?
Is there a marketplace, right? Because Daniel, I think you nailed it. That a lot of the presentations we've seen on EVTOLs have to do with specific locations in the United States where these particular aircraft can be utilized. San Francisco, Houston, and maybe Chicago, definitely New York. New York's the number one that gets thrown out a lot. So if your time duration goes down in terms of the length of flight go down, what does that do to revenue streams? So say you guaranteed this aircraft's going to fly 30 minutes with the FAA mandated reserve, and it's now 25. What does that do to your profitability? Don't know, right? It may, if it doesn't go 30 minutes, do you not make that flight, right? So if you're going from, I don't even know the distances. If you're going from Manhattan to LaGuardia, I don't even know what that distance is. But if you're just short of that, essentially that market gets wiped away because you can't make it. What do you do?
Yeah, that's an interesting thing. It's not like a car. You just like get out, you walk the last mile. Like if you can't make it to that airport, you just can't make it at all. That is a really interesting point. Yeah, there's no night getting 90% of the way there. You've got to get there.
That's right, and no one's going to buy the aircraft if you can't show that you can do those routes. So that distance is really super critical in the profitability of these companies, but we just haven't seen any demonstration of it yet. And I always go back to the Wright brothers flying around the farm fields of Ohio, and that's what they did. They flew around the farm fields of Ohio to demonstrate they could stay in the air a long time, and we still need that sort of validation. If the Wright brothers were doing it back in 1908 or whenever that was, which is probably 1908, 1909, then we're in 2021. We should be able to show that because humans haven't changed all that much. We need to see it to believe it. Sort of the Missouri show me state thing. We need to be able to see it to believe it. And right now we haven't seen it from anybody. It's not a Joby specific thing. We haven't seen it from any eVTOL maker that they can do this. Even EHang hasn't shown they can do it. So what are we going to do? At what point are we going to see it? And I kind of feel like you, Dan. I'm not sure we're going to see it in 2021. I don't know if we're going to see it this year. Kind of doubt it. But it'd be great if I could be wrong, but it'd be great if we did. But it doesn't feel like it today, this being March 2021. I don't think we're going to run out of time to get that done this year.
All right. Well, that'll do it for today's episode of Struck. If you're new to the show, thank you so much for listening, and please leave a review and subscribe on iTunes, Spotify, or wherever you listen to podcasts. Check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from the show. And follow us on LinkedIn, Twitter, Instagram, and Facebook. Our handle is @WGLightning. Tune in next Tuesday for another great episode on aviation, aerospace engineering, and lightning protection. Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.